Geometry Trig Honors, 7.6 double angle and half angle formulas. So, hey, we just worked with all the sum and difference formulas, and now we get to get our butts kicked with double angle formulas. Woohoo! Well, they're actually not too bad. Okay, that's a lie. They're all horrible, but you'll get through it. Notice there's only one for sine, and it's relatively easy to remember. Sine of 2 theta, 2 sine of cosine theta. This one's kind of nice for going backwards. Hey, I got sine and cosine. No, I don't. So you'll see it lots of different places. By the way, where do we get this? We just did the sine of theta plus theta, and that's what we get. Same thing here. We did cosine of theta plus theta, and then we used the trig identity of sine squared plus cosine squared equals 1 to make a couple more. I don't know which one comes first. It doesn't really matter. Now you got to get used to applying them. So sine of theta is 4/5. We're in quadrant 2. So 4/5, -3. I noticed that cosine and sine are in all these formulas, so I might as well write down what cosine of theta is. -3/5, and try not to forget, it's right there. Sine of 2 theta is 2 times, I'll write it out the first few times, sine of theta, cosine of theta. 2 times 4/5 times -3/5. -24. -24 25ths, which tells me that cosine of 2 theta, if I think about this, goodness gracious, it's going to be probably, I'm going to take a wild guess, 7/25. Let's go find out. So which one do we want to use? I like using the first one, the second one. It's the easiest in terms of not having to redo a lot of work. Cosine of 2 theta equals 1 minus 2 sine squared theta. 1 minus 2 times 4/5 squared. 1 minus 2 times 16, 32 25ths. At which point, oh, I must have screwed up. Something's wrong here. 25, darn, I was close. Over 25 minus 32 over 25 equals -7 25ths. So you might say, well, how did I kind of know that? And you don't need to know that. It's just kind of handy to think this way. But these are sets of angles. You know, if you want to call it x, sine of x and cosine of x. So they form a triple somewhere. I'll call it 2 theta. And we found out that sine was -24/25. Well, I happen to know the triple, -7. So a lot of people say, well, can I just do it that way? And sure, why not? Do whatever you want. Lots of different ways to get things done, and intelligent people remember it in different ways that appeal to them. Let's do some deriving, which I have studiously avoided so far. Yeah, keep forgetting my formulas. Tangent theta, keep the sign positive, over 1 minus tangent of theta, tangent of theta. So tangent of 2 theta is 2 tangent of theta over 1 minus, my computer's glitching, tangent squared theta. Another formula to remember. It was really hard to derive it, I suppose, but how about writing sine of 3 theta in terms of sine of theta and cosine of theta? This looks like it's going to be hard, but I know we can just do sine of 2 theta plus theta. Sine, cosine, cosine, sine. Sine of 2 theta, cosine of theta. Sine stays the same. Cosine of 2 theta, sine of 2 theta. Sine, cosine, cosine, sine. 2 sine of theta, cosine of theta. So just sub that. Cosine of theta plus, cosine of 2 theta. I wonder what I should change that into. I've got lots of options. Let's go with 1 minus sine squared theta. I mean, literally, it doesn't matter. You can pick whatever you want, but 1 minus sine squared theta times 2 sine of theta. Ugh, that was horrible. Theta cosine of theta. Yeah, let's just see where it takes us. So I'll put them all in sine of theta. Why not? Sine of theta. This is cosine squared. So let's 1 minus sine squared theta plus. I'm not going to distribute this because I can factor it out. But I got a cosine over there. So I didn't have to simplify it, but I thought I should. Nah, I'll leave it as is. It doesn't really matter. And I'm not even going to simplify that. I'll just leave it as is. 2 sine of theta cosine squared theta plus 2 sine of theta cosine of theta minus 2 sine to the third theta cosine of theta. I don't know if I even have anything in there that I could combine as like terms. Yeah, I could mess with it some more. There's really no point. All right, so that's how we can break those down. There's no formulas to remember. But you can also rearrange formulas to reduce trig functions from second order to first order. So this is kind of cool, kind of a big deal. It all is based off of the cosine of 2 theta equaling 1 minus 2 sine squared theta. So move that over here. 2 sine squared theta equals cosine of 2 theta. No, it doesn't. 1 minus cosine of 2 theta. Divide both sides by 2. And there we go. 1 minus cosine of 2 theta over 2. This is probably the only formula I'll tell you to memorize. You will need it for calculus because you cannot take an integral of that very easily, but you can of that. So it's one of the few. Do some fancy math over here, you will get, oddly, what's with all the cosines, over 2. And then, hey, I know how to find tangent squared theta. It's 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Hopefully you're not asking me what happened to the 2's. Does that formula help me in calculus? No, not really. I'd have to keep going from here and maybe multiply by a conjugate or something. No, I wouldn't do that, but yeah. Anyway, so here's a problem. Reduce cosine of theta to the fourth so that it does not have a power of sine or cosine greater than 1. So these are kind of a hassle. This is, evil math teacher stuff. Let's screw with our students whenever possible. Make them thankful that, they have like real lives outside of the classroom. And we could do that. And then the one we just wrote, 1 plus cosine of 2 theta over 2 squared. Blast that out, pull the 1/2 out front so that it's 1/4. And we get 1 plus 2 cosine of 2 theta plus cosine squared 2 theta. And we can get rid of, what am I doing here? And we can distribute through the 1/4, I suppose. Now we want to get rid of the cosine squared 2 theta. So, hey, we know what to do. The rest comes along for the ride. Cosine squared is, I'm going to put the whole 1/2 out front. plus. Now it's not 2 theta anymore. It's 2 times 2 theta. What the heck, I can't suddenly draw parentheses. There we go. And clean it all up. Too late. 1/4 plus cosine of 2 theta over 2 plus 1 plus cosine of... I gotta pull that part out. No, I'm good. 1 cosine of 4 theta over 8. I could also pull out the 1/8 and put it up here and make that 3/8. So it's another option. Something like this. Whatever you want to do. Where you're taking this is up to you. It's a nice handy tool going forward. I'll leave it like that for now. Woo! Cranking out the math. So now I give you an equation. And you say, I don't know what the heck to do with this. I warned you about this. Multiply by 2 sine of theta cosine of theta equals -1. Hey, I know what that looks like. That looks an awful lot like sine of 2 theta. Now I do my little u substitution. Where does sine of u equal -1 when u equals 3 pi over 2? 2 theta equals 3 pi over 2. We better check 7 pi over 2. The next one down the pipe just in case. Theta equals 3 pi over 4 and 7 pi over 4. They are both inside, so we are good to go. Oh man, I'm starting to get a handle on these formulas. And what do? We keep throwing new ones at you. Well, these are called half angle formulas, and they're going to look real familiar. You're going to say, hey, I just saw something like this. We had like a 2 theta here or a 2 theta there or something like that, and we just, yeah. We're taking the square root of both sides. You got to know what quadrant you're in so you know if it's positive or negative, and that can be a little tricky, but not a big deal. We'll blast this out. So do cosine of 15 degrees, and you can say, wait a minute, that's 45 minus 30. I can do sum or difference. So yeah, but we're doing it a different way now. So the cosine of 15 degrees equals cosine of 30 over 2, which according to our little formula is equal to plus or minus. Well, I don't need plus or minus. I'm in the first quadrant. I know where I'm at. Thank you. Plus square root of 1 plus cosine of 30 over 2. Very busy, complicated way. You're probably saying, I would totally use a sum or difference. I really don't want to see a radical. And then the even weirder part is that this radical is equal to like the root 6 minus root 2 thing we did last lesson. But yeah, it's just another thing we can do. Autosave. Equals square root of cosine of 30 is root 3 over 2. 2 over 2 plus root 3 over 2 all over 2. 2's drop down, we take square root. So we get square root of, well, this is hideous, 2 plus root 3 over 2. Can't be serious with this. Yes, yes, we can. And what about sine of -15? Sine of -30 over 2. So we take that and we run with our new formula. -15 will be negative, so negative square root 1 minus cosine of -30. You're probably thinking, whoa, those negatives are going to mess me up. Yep, they're going to be a pain. And cosine of -30 is root 3 over 2. 2 over 2 minus root 3 over 2. What's with the 2 over 2? Yeah, I've seen this movie before. Equals negative square root of 2 minus square root of 3 all over 2. Which point you say, yeah, that's much simpler. Thanks for nothing. Well, this is the math we're doing, so see where it takes you. A little bit more. Hopefully not too much. So I'm going crazy. I don't know about you. If cosine of alpha equals negative 3/5, sine of alpha, find sine of alpha over 2, cosine alpha over 2, and tangent of alpha over 2. Well, here's a nice one. I don't think I really need to draw this. I only need to use the quadrant to figure out whether this is, since I got the plus or minuses, whether it's positive or not. This one's going to be positive because let's just say this is 180 and this is 270. We want half that angle, so it's going to be somewhere between 90 and 135. So I know that one's going to be positive. However, cosine, oh yeah, so I know this one's going to be negative. Hey, there you go. This one's going to be negative. Great, so that's the only thing I use quadrant for, not like last time. So it was never a bad idea to draw them in. So off we go. Sine of alpha over 2 equals positive square root of 1 minus negative 3/5 over 2. Square root of 5 over 5, 8 over 5, 8 over 10, 4 over 5. And I'm going to rationalize the heck out of it all in one clean step because I've seen this movie before. I know where it's ending. Make sure you know what you're doing there. Cosine of alpha over 2 is negative square root of 1 plus negative 3/5 over 2. 5 over 5, 2 over 5, 2's cancel, 1 over 5 gives me negative root 5 over 5. We're cranking out the math now. Tangent equals negative and it's a big square root with top and bottom. 1 minus negative 3/5 over 1 plus negative 3/5 equals negative 5 over 5 plus 3, 8/5 over 2/5 equals 5's cancel, with the 4, negative 2. That's weird. Works out quite nicely. That can't be right, but it is. That's it. Man, that's a lot of work. I keep saying it, but I keep meaning it. Happy mathing. You got a lot to do.